Welcome back to the deep dive where we do a deep dive into your sources and pull out the good stuff. Today, it's all AI, all the time, thanks to Jensen Huang's keynote, CEO of Nvidia,
Yeah.
for those who maybe aren't as familiar. And you sent over some highlights, so let's figure out why everyone's calling this such a pivotal moment for AI, huh?
It's a good time to be looking at this stuff, that's for sure. Hong's not just showing off new gadgets, he's like laying out this whole vision for how AI changes, well, computing in general. I mean, we're talking gaming, obviously, but also things like scientific research. So it's not just the tech, it's how we actually live and work that's changing.
Huge scope.
Yeah.
But he starts off kind of grounding us, taking us back, uses Sega's Virtual Fighter as
Mm.
this example. Remember that? Blocky, kind of classic.
Oh, for sure.
But AI rendering has like changed it. It looks almost like a movie now, right?
It's nuts. I mean, almost unrecognizable. And that really shows you how far we've come since those early days of programmable GPUs.
Yeah, it's a good visual. But then he jumps into some pretty complex stuff. These scaling laws, he calls them, shaping the future of AI, how it develops. Three of them, he says. Pre-training, post-training, and then test time scaling.
It's more than just building bigger AI models, it's about smarts. These laws, they basically say how AI gets more capable, over time. Pre-training, that's like feeding it tons of data. The foundation, you could say.
So like giving an AI a giant textbook.
Hmm.
Would post-training then be, I don't know, like giving it a tutor to really dive deep into that textbook?
Pretty good analogy. Post-training, that uses stuff like reinforcement learning, where the AI gets feedback, refines what it does, so honing its skills in a particular area, you could say. And then there's test time scaling, which is how the AI changes its approach live as it's working on a problem.
So learning how to learn better, is that what we're saying?
Yeah.
Get meta, huh?
Exactly. Test time lets it shift resources dynamically. Tough problem. It can break it down into smaller steps or throw more processing power at it, almost like it's developing those critical thinking skills on the fly.
Okay, so smarter AIs guided by these laws.
Yeah.
But where does NVIDIA fit into all this?
Well, that's where Huang brings in their Blackwell architecture. Basically, this is the engine running this new era of AI, not just data centers. We're talking massive AI factories. Performance and energy efficiency, that's the key.
He dropped this crazy stat that one Blackwell system, it could handle like the entire world's internet traffic all at once.
It's mind-boggling, the scale of what we're talking about. But then he ties it back to us, regular folks. GeForce GPUs, for gaming. But they've actually helped make AI development more accessible, wouldn't you say?
Makes sense. Most people don't have a Blackwell system just, sitting around in their basement.
Right. GeForce has given people the tools to experiment with AI. And now it gets interesting. AI is changing GeForce itself. Features like DLSS, deep learning supersampling.
He had that demo, the one where AI was making like 3 out of every 4 pixels in the game. Blew my mind a little. So AI is being used to improve AI, like a feedback loop.
Exactly. And it goes beyond gaming. Think film, animation, medical imaging, all sorts of visualization stuff.
So AI making more advanced AI, which then makes our everyday tech better. It's all kind of intertwined, huh?
It is, and it leads right into Huang's next big thing, agentic AI. Systems designed to work on their own, doing complex stuff.
That's getting into sci-fi territory, right?
Yeah.
Like having a personal AI that not only organizes your day, but also, I don't know, does research for you, comes up with ideas.
That's the idea. AI that can act independently, learn from experience, handle new situations. Imagine having an AI to help you work, find information, even generate creative stuff.
So not just AI making things look good, but actually doing things for us. How does that even happen?
Well, Huang talks about empowering developers. NVIDIA NIMs, they're like AI microservices. And then Nemo, which is their digital employee onboarding and training platform. They're giving developers the tools to build this next generation of AI, you see.
Almost like they're creating, what, an AI workforce.
It is, and that takes us to an even wilder concept, physical AI.
Okay, now hold on. We've gone from games to AI thinking for itself. Where does physical come in?
Think AI that can interact with and understand the real physical world. Huang introduces NVIDIA Cosmos, the world's first world foundation model, and it's built for training robots and other physical AI systems.
So robots, that's where we're going with this.
Exactly. But not just any robots. These are robots that learn not from lines of code, but from real-world data. Imagine a robot learning by watching tons of videos, developing an understanding of physics, movement, all that.
That is wild. But how does that even work? Training a robot with video.
Well, that's what we'll get into in the next part of our deep dive. We'll explore how this tech is creating robots that work with us, adapt to our world, and maybe even change entire industries.
Okay, yeah, I'm hooked now. We'll be right back after a quick break to explore this mind-blowing world of physical AI. Don't go anywhere.
So we were talking about, training robots with video, using NVIDIA's Cosmos platform. It's like connecting AI's digital world with, well, with the real world we live in. Kind of a big deal.
It is a big leap. I mean,
Mm.
from AI making pixels in a game to AI that understands, like interacts with physical stuff. How's that even possible?
Deep learning, that's the key. Cosmos lets robots learn from, well, huge amounts of video, real-world interactions captured on video. It's like giving them a lifetime of experience all at once.
Instead of programming every motion, every reaction, it just learns by example, by seeing how things work.
Exactly. It's a more nuanced way for them to understand physics, movement, even how we humans behave. They can anticipate actions, adapt to changes, handle objects more naturally.
So like developing a sort of intuition, like a kid learning by watching, trying things out.
That's a good way to put it. And that's where Huang introduces NVIDIA Isaac Groot. This platform is all about making what he calls general-purpose robots. Not just for one specific task, but adaptable, able to learn new things, and designed to work with humans.
So not just robots on assembly lines, but robots that could, I don't know, collaborate with us in all sorts of environments.
Exactly. Healthcare, warehouses, disaster relief, even scientific research. The possibilities are huge.
Exciting, but kind of scary too, right? I
Yeah.
mean, robots as coworkers, what does that even mean for us?
Yeah, that's something we're all going to have to think about as this tech gets more common. But Huang emphasizes that the point isn't to replace us, it's to, enhance what we can do, create new opportunities.
He did this demo, a human wearing that Apple Vision Pro headset, controlling a robot in like a virtual world. What was the point of that?
Safe training. That's the key. By controlling a robot virtually, you can teach it stuff, test its limits, even put it in dangerous situations. But no real-world risk.
Like a flight simulator, but for robots.
Exactly. Speeds up the learning process, makes sure they're ready for, well, for whatever the real world throws at them.
Feels like just the beginning for robotics, Where do you see this going in the next few years?
Well, Huang called this the, quote, ChatGPT moment for robotics, and I think he might be right. ChatGPT made AI accessible to, well, everyone, and these advances. They could do the same for sophisticated robots, a whole new world of possibilities.
So instead of robots only in factories or labs, we might start seeing them in everyday life, our homes, workplaces, like that.
It's possible, but with that accessibility comes responsibility, right?
Yeah.
Making sure these robots are developed ethically, thinking about how they impact society.
Right. It's not just the tech itself. It's about how we use it, what it means for our lives, our world, bigger picture stuff.
Exactly. And speaking of impact, Huang doesn't just talk about robots. He also highlights how AI is changing other industries like transportation, self-driving cars, all that.
Yeah. Their work with Tesla, Mercedes-Benz, even Toyota, building this new generation of autonomous vehicles.
DriveOS, that's their software platform for those vehicles. It's achieved the highest level of functional safety certification for cars.
That's a big deal, right? Means it meets those really strict safety standards, which is super important as we, move toward more self-driving cars on the road.
It shows they're not just innovating, but doing it responsibly, focusing on safety. But it's not just cars. He also talked about working with Kion and Accenture, bringing AI into warehouses, logistics, that kind of thing.
Optimizing complex systems, making them more efficient, out in the real world, perfect example of that, right?
It is. It shows AI isn't just flashy demos and, robots in the future. It's about solving real problems, making things work better, ultimately improving our lives.
It's amazing how broad this all is.
Yeah.
From games to robots, self-driving cars, warehouse automation. AI is the thread that connects it all.
And it's moving so fast. It feels like every few months there's some breakthrough, some new way to use AI that pushes the limits of what we thought was possible.
It's like living in a sci-fi movie, except it's real. But before we go too far down that rabbit hole, there's one more thing from Huang's vision that we need to talk about. This idea of democratizing AI.
And that's a perfect segue into the next part of our deep dive. We'll look at how NVIDIA is making AI accessible to everyone, not just big companies or research labs.
We'll be right back to talk about the future of AI and how we can all be a part of shaping this incredible tech revolution. Okay, so before the break, we were talking about, well, making AI accessible, right? Democratizing it. That's what they call it. Big theme in Huang's keynote.
Yeah, a big one. His vision is that AI isn't just this, tool for the big guys, the tech giants, research labs. It's something that can empower anybody, fuel creativity, drive innovation everywhere, you name it.
He even announced this thing, Project Digits, called it a personal AI supercomputer. Is that a real thing? A supercomputer on your desk?
That's what he's saying. And the key is this new chip, GB110. Nvidia worked with MediaTek on it, Grace CPU, Blackwell GPU, all linked up with NVLink technology. Basically a mini powerhouse.
So like shrinking those massive AI factories we talked about, fitting that power into something,
Yeah.
desktop size.
Exactly. And Huang thinks this is just the start. He sees a future where every software engineer, artist, anybody creative has that level of AI power at their fingertips.
Bold vision, but also kind of exciting, right? What could people do if they had access like that?
Think about it. Students learning faster, artists creating totally new kinds of art, entrepreneurs building things we haven't even imagined. It really could change who gets to use AI and what they do with it.
But it's not just about, individuals. Huang also talked about AI tackling big global problems.
All right, healthcare, education, sustainability, those were his examples. AI for personalized medicine, making education more engaging, even finding solutions for climate change.
Like he's saying, AI isn't just about cool gadgets or automating jobs. It's about, I don't know, using our smarts to make the world better.
Yeah, that's a core part of his message. Optimism, this belief that AI can be a force for good.
It's inspiring, honestly. Feels like we're right on the edge of something huge. But looking back at everything we've covered, it's a letter AT. Video games, robots learning from videos, personal supercomputers. What sticks with you from this whole deep dive?
The pace of it all, that's what gets me. It's not just small steps, it's like the whole way we think about computing is changing. A little scary, but also incredibly exciting. I mean, what will the world look like in 5, 10 years with AI woven into everything like this?
That's the question, isn't it? A little nervous, yeah. But mostly, yeah, I want to see what happens. And the cool part is, with tools like Nvidia's making, we get to be part of that future.
That's an important point. We're not just watching this happen. We can learn about AI, try it out, help shape where it goes. Doesn't matter if you're a programmer or just, curious. There are ways to get involved with this stuff.
Feels like the beginning of something big, that's for sure.
Mm.
And who knows what's next, right? Anyway, Kev, thanks for joining us on this deep dive into the world of AI. It's been a blast.
Absolutely. Great conversation.
And if you want to learn more about anything we talked about today, check out the links in the show notes. Oh, and don't forget to subscribe to the channel. We've got plenty more deep dives coming your way. Until next time.